start again. So gonna explain to you how in a rather simple way you can use an optimization model to find what is a yield curve for a given bond market, or what is a thermal structure of interest rates for a given bond market. And the method for doing that is called bootstrapping. Bootstrapping is being used in, it has different meanings under different contexts, but the context in which we're using bootstrapping is bootstrapping a thermal structure of interest rates. So bootstrapping a yield curve from the prices of a given bond market. Right, but just before that, I want to draw your attention to what the origin of the term bootstrapping comes from, because that's probably a term you've already heard if you had a course in time series analysis or statistics. It's not sure you necessarily have Googled it and seen what it means, but essentially bootstrapping, it goes back to the German legend of a Baron Munchausen. I think probably our German students here. You haven't heard about the Baron Munchausen? You don't want you learned that in school, I guess, right? And there was this guy who was a pilot, was he? It's a legendary pilot, right?
The author of this story wrote several short stories where things happen which normally aren't happening. So kind of stories which tell mythos.
Yeah, there's the myths. Yeah, there's a mythical stories. Yeah, so that's and there's one of these stories probably is this very famous. That this guy who was actually saying that he could do all the crazy stuff, that he could lift himself up from his bootstraps, and that's for some reason the statisticians have taken this term to them, and they whenever they want to work with essentially replacing missing data with some good estimates, they will refer to that as bootstrapping. So in this case, what is then bootstrapping? Bootstrapping actually could be defined in particular in this shape and form, right? So this is bootstrapping, the bootstrapping model for term structure of interest rates. So let's get into what it actually means. So first, the ingredients that we've got in here. We've got the prices of bonds in a given bond market. These are described as the PIs. And then we have the cash flows for those bonds. So if I go to any particular bond market, let's say the Danish government bond market, then I can go in on a daily basis and I can observe what are the prices of those bonds. And for all those bonds, it's specified what is the horizon and what are the coupons. And based on that, I can decide what are the Fs, the cash flows. What I'm missing are the Rs, right? So again, it goes back to prices are what you get from a bond market. From them, you have to derive interest rates. It's not the other way around. That said, of course, then these markets are ongoing. So based on prices, somebody has already decided what are the current level of interest rates. So if you want to introduce a new bond into this market, obviously you will use those interest rates which are derived from that market. You will use that to kind of estimate what the price of your new bond which you're introducing to the market should be. And then you will, of course, if somebody gives you a price which is higher than that, you will say, yes, thanks to that. Or if it's lower than that, you might want to push it a bit more forward, right? So that's how it works in the bond markets with regards to the prices and the dynamic between prices and interest rates. But here we are not given prices of a number of bonds, and we have their cash flows, and we want to decide what the Rs are. And I won't go into details of this one for now, but just suffice to say, well, that this inequality means that forward rates should be positive. So we don't allow negative forward rates. So, and this is kind of just to ensure that the way that you are finding your Rs are as reasonable as possible. Because as we saw here, if you go back to, this is the price formula for a bullet bond for this 4-year bond, let's say, in this particular case. And as you said, there are many answers for R1 to R4, right? And even if I want to, so let's see what we can do here. so if I observed, so this was a 4-year bond, and if I give you another bond, let's say this is, I'll give you a 2-year bond, which has got a price of, a coupon of, let's say, 2 rather than 5. So let's say the price for that is 97, and then you have 2 to the power of 1 plus R1 to the power of 1 plus, then in second year is 102 divided by 1 plus R2 to the power of 2, right? So just to make it simple, this is one bond market, which is only comprised of 2 bonds. There is a 2-year bullet bond, and there's a 4-year bullet bond, right? With the prices of 97 and 98. What this market has in common are the term structure of interest rates, right? So it's the same R1, which has to be applied to the whole market, the same R2. And if you add more bonds, then there would be more of these R's to share across different bonds, right? But just to make it simple, just to illustrate how the model works, what the objective function tells you is that you have to minimize the difference of the price of the individual bonds and the sum of discounted cash flows for that one. And then you're summing that, and you're minimizing the squared sums of those differences, right? So you're minimizing the squared sums of the differences of prices and the sum of their discounted cash flows. And what does that mean? Essentially, first let's write this up. So that would be, if I don't want to write this whole thing up again. So I'm minimizing. Then I say, well, then I have 98 minus this whole thing, right? So that's the one thing. That's this difference between 98 and this thing. And I'll say that to the power of 2, because I don't care if the difference is positive or negative. I essentially want to find some R's which make sure that what we have in the parentheses here gets as close to the price as possible, because that's essentially the idea with the price formula, right? You want to have some R's in such a way that if I put them into the price formula, they would give me exactly price. So then I say, well, I take price minus this sum and the whole thing to the power of 2, and then I'll just put some extra terms for the second-year bond. Then I'll say, well, this thing plus for the second-year bond, then I have for a 2-year bond, 97 minus the cash flow to the power of 2, and so on if I had more bonds, right? So I'm minimizing squared sum of differences, right? Does it make sense? So that's pretty simple. It's kind of a least square optimization method that you might know from a course in statistics. And there are many different, you don't necessarily need an advanced optimization tool like what we have in GAMS and with some of the nonlinear solvers, but we have the tool, so we're going to use it today in order to do exactly that. So I've given you a number of bonds for a given market. There are some 7, 8 bonds, which are of this bullet. They are bullet bonds, and I want you exactly to implement this model in GAMS for that particular market and come up with this term structure of interest rates for that particular market. All right, so this is one of the assignments of today. And again, back to this one, you can try it with and without this equation. And then it's also left for you as an exercise to figure out in what way that constraint essentially means that forward rates are not allowed to be negative, right? So this is one constraint. Now there comes the question: what does it mean essentially that we don't want the forward rates to be negative? Why did we think that this is a good idea, right? So for one thing, can interest rates be negative? Yeah. Yes. If it was 10 years back, when I started this course back in 2005, when I asked the students, then there will be a resounding no, it's not possible. But now it's, well, have you seen that it's possible, right? And if you go further back, probably there were many economy professors who would say it's not possible. You can't get negative interest rates. And it makes some kind of sense, right? Because what does it mean that we have negative interest rates? Why is it, to begin with? Let's put it the other way. Why is it that, like, if you go 20 years back, then some finance professor would say, well, negative rates, they don't make sense. And we can assume no negative interest rates or no negative forward rates. Yeah.
No incentive to give a loan.
Right, because you can keep the money rather than, I mean, that's the sense of having negative rates means that you will, if you would lend your money to me, then also you have to pay me for lending me money rather than I have to pay you interest rates for. So it's kind of amounts to going to a restaurant, eating, and then getting paid for it, right? You get a service, and you also get paid for getting the service, right? But then again, maybe that's not quite a fair comparison. And can somebody think of why is it anyway? Because if the rationale was correct, and it is somewhat correct, right? That it's, I mean, I can keep the money always at home, put it under my mattress, right? And rather than having to pay the bank for depositing my money at some account, I can just get 0%, right? Just my money. If I put it in the bank, it loses actually some value because I have to pay, actually, rather than receive interest rate, I have to pay interest rate on it. But why is it people still would do that? Because it does happen, as you said, it's true. We're observing as we talk. We're observing in Denmark, probably in Germany, we observe negative interest rates. Why is it that people actually would accept to lend money to the bank and then pay them for it? Well, I mean, inflation is positive actually currently, right? So there is positive inflation is about somewhere between 1% and 2%. So if anything, then inflation actually you have to get compensated for that, right? So you have to have, if I give the bank 100 krona, then I expect at least to get the inflation back. But the fact here is, I mean, that my money is losing value because of inflation. But on top of it, if I put it in the bank, if there's negative interest rate, which is the case in some countries, including this one, then you will actually have to pay also the bank. So you actually pay indirectly for the inflation, but also you pay directly an interest rate to the bank, being the negative interest rate. But still, people would do that. It's safer. So that's because if it's that makes good sense. So maybe if I have, I don't know, 10,000 krona or 100,000 krona, I want to keep it at home, you know. But if I had bigger savings, you know, if I have, I don't know, hundreds of thousands of krona or millions of krona, if I have my pension savings, or whatever that is, and if I need the money in half a year, 1 year, you know, I simply wouldn't want to have all that cash at home. The other thing is maybe it's not even practical. Where do you get all that cash these days, right?
In the case of dramatic financial scenarios, for example, when the crisis occurs, the first action some governments have is to limit the amount of money you can withdraw from the banks.
Mm-hmm. Right. So that is in some countries. What you're saying is that it could be in some cases that you can't actually withdraw the money. If in the case of capital control that you have in countries like Greece, or I think Cyprus had it some years back, I think still they have it to some degree, that you can't just get the money out. But the case actually with those particular countries is that they actually pay you still a positive interest rate. So that's not the case in a country like Denmark. Here you can essentially take all your money out from the bank, but people wouldn't do that. So one reason was safety. Of course, you want to have your money in there. But there's another reason that is probably even more important. So that's the actual driver for why we have negative interest rates. Yeah.
Something valuta related?
Yeah, with the exchange rate, something to do with the exchange rates. Yeah, foreign. Yeah, yeah. Right, so that is you're getting. Can you be more specific? It's got something to do with that. Yeah.
We are bound to the euro.
Mm-hmm.
So the Danish krone cannot increase in value unless the euro does.
Right. So we have the fixed rate. We have the fixed rate exchange rate between the Danish krona and the euro, and that could. I mean, essentially, and we have the whole euro construction essentially also across Europe. So the euro construction essentially means that we have a fixed rate. Exchange mechanism between different European countries, the euro countries. And essentially what happens in that case is that if you have well, let's say if you take the extreme example of Greece, that have been there have been talks of Grexit. Now, well, we have Brexit, but also you've probably heard of Grexit, the case of Greece leaving the European, the monetary union, the EU, not the EU, but the euro, because, well, they were kind of not living up by the terms of the euro, and so they might actually be expelled from the monetary union. But I mean, of course, then the rest of the countries, they try to keep them in the union because, well, Greeks getting out, that would be a catastrophe for not only the Greece but also for the rest of the monetary union as well. But if that happened, let's say if I was a Greek investor, or if I was and if I had millions of I would call it in citations Greek euro in my Greek bank account, would I not be a bit worried of a scenario like Grexit, right? That all of a sudden overnight, for some reason, Greece is going to be expelled from the monetary union, right? And then what happens is that exactly what you explained, is that you would get a kind of a capital restrictions. You will get capital control. So all the money would be frozen overnight. So all my euros overnight will turn into drachmas, or whatever they might want to call it after that scenario happens. And because there is only one currency, so essentially then you can start letting the market decide what the exchange rate should be from then on. Because right now, the exchange rate, of course, there is no exchange rate because we all have euros. But if that is going to happen, then we'll start with, let's just say we start with a 1-to-1 between euro, which is the rest of the European Union currency, and the new drachma, which is, let's say, coming into Greece after Brexit. So you start with 1/1, and what's going to happen the day after that is that the money is going to devaluate. So all of a sudden, maybe overnight, it's going to devaluate from 1 to 0.5. So essentially meaning that overnight, your money could be reduced to half, right? So for that reason, if I was a Greek investor, I might have an incentive to put some of my money in a German bank or invest it in Denmark to make sure that, well, some of my money or most of my money, the ones I can get out, are in the safe havens, right? So even though for that I'm even willing to pay a little bit of negative interest rates. So we are seeing this very extreme scenario. So euro is kind of a new experiment, is more of a political experiment, and this is one of the kind of unintended consequences of a structure like that. So if we didn't have that kind of structure in place, probably we wouldn't have seen negative rates. So all that to bring you back to this equation here, saying essentially that negative rates are not possible or are not desirable in general. It actually makes very good sense, but from next week, when we actually want to work with real data, fresh data, new data, you have to actually get rid of this one. You have to kick it out because we do allow negative rates, and that would be an exercise for you to work with. Have a question?
But why the banks give a loan for negative interest?
Well, that's a good question. It's many times essentially they even though they get, because essentially banks are in the business of getting the money in the one hand and then lending it out in the other hand, right? So let's say if I was a bank and you were the investor, you were the Greek investor willing to pay me 1%, so that's negative 1% rate and I'm a German bank for having your money in my bank, right? Or I was a Danish bank. Right, then you come and want to your Danish business and you want to borrow some money from me. I'm willing to even give you that money with minus 0.5%. So I still pay you, but I pay you less than you pay me, right? So as far as that difference is positive, the banks are happy. They live on the margin, which could be, well, 0.5%, let's say, in that particular case. Well, in both cases, we still have negative rates. But when it comes to, for example, mortgage-backed securities, normally the margin is so big that even though the investors, let's say the Danish pension funds, they would pay something like 0.5%. So we have a negative interest rate of 0.5%. But you, as the home buyer in Denmark, you will still pay maybe 0.5% because the margin is somewhere like 1% or greater than 1%. So in many cases, for the final consumers, they would still pay a positive rate when they borrow the money. But when you're lending the money as a private consumer to the banks, in many cases today, if the money you're depositing in a Danish bank greater than 100,000 kroner, if you want to just deposit it in a normal bank account, that's going to cost you. It's cost probably somewhere between -0.5% to 1%. All right? Any other questions regarding bootstrapping or negative interest rates? No? Otherwise, there's going to be an exercise you're going to work with, and I'm sure there will be some discussion there.